you could say that you know something is true without actually revealing that something. Create a receipt to say, hey, it's been verified immediately within milliseconds. A provable lottery, that lotteries are being run in a way that is fair. We can bring costs lower to accelerate the verification process. The next iteration of Horizen, which is Horizen 2.
Welcome everyone. I'm thrilled to introduce Zain from zkVerify, a partner of Gateway. And today we're talking about zk technology. Zain, you will be the perfect person to tell about this, since you are the prof in zk, I believe. So let's get started. Could you start with introducing yourself and your journey? How did you come up with crypto industry?
Yeah. Alex, I'm really excited to be here and nice to see everyone. I'm Zain, CTO of Horizen Labs. And at Horizen Labs, we are focused on two projects, really. And the two projects are the Horizen blockchain. It's the home to the Zen cryptocurrency. And the second one is zkVerify. And that is an L1 decentralized blockchain that's solely focused on verifying proofs at scale. I entered the industry about 3.5 years ago, and I was attracted to the technology behind it and the ideals of decentralization, having a centralized authority, and all the innovation that's happening. I came from another startup, which I was at for 7 years, a traditional Web2 startup, and helped to bring it public. And I've got to meet some really cool crypto folks. And now I'm here at DevCon, really excited.
Cool. Great to have you here with us.
Yeah.
So Horizen Labs have been in the industry in the zero-knowledge space for a while. So could you please tell us about what zero-knowledge proof actually is?
Yes, Horizen as a blockchain has been around since 2017. So one of the first zk projects, we were a fork of Zcash, which is a fork of Bitcoin. And what is a zero-knowledge proof? Zero-knowledge proofs have been around before blockchain. So it was introduced in a paper in 1985. And it really is a cryptographic advancement. So this like mathematical innovation where you could say that you know something is true without actually revealing that something. So in a way, it's that it could be used for that something could be a secret, a value. It could be an entire computation. And so it's really gotten great use in terms of blockchains, especially for scalability and also privacy.
zk rollups are becoming more and more popular, and we at Gateway, we specialize mostly in zk rollups, not optimistic set. So in order to run a zk rollup, we have a dedicated zk prover for each particular rollup we deploy. zk prover itself is a very expensive and powerful machine, a computer. So to run the zk rollup, we need first to generate zk proof with the help of this prover machine, and then we need to settle it to verify. Like we are usually doing this, settling this zk proof on Ethereum. But you have something to offer, like a better way and better solution. Could you tell us about this?
Yes. That's a good way of putting it in terms of provers, the overall L2 framework, and verification on the L1, which is Ethereum. And yes, for zkVerify, we do feel that in terms of the proof lifecycle, there's the proof generation, the proof aggregation, and the proof verification. And we're solely focused on innovating and being the most cost-efficient layer for verification. And so our L1 blockchain takes in all different types of proofs It could be right now in testnet we support Broth16, we support Flock, UltraPlock, Proof of SQL, and many others. And so we will accept the different proofs. It could be from a prover from Gateway or anywhere else. It could be any proof generating app. And then we create a receipt back to anybody who's giving us the proof to say, hey, it's been verified immediately within milliseconds. But we also take it and aggregate it. So we aggregate it in a way where there are multiple different proof types, and then we send that almost aggregated receipt back to the other chains. So that could be Ethereum L1, could be, right now we also support broadcasting out to 8-chain testnet, the Curtis testnet, our Horizen Eon EVM chain, and we're supporting new chains all the time.
Okay, so you mentioned there are different types of zk proofs that you support. Does it depend on the type of network that is generating it, or how does it work?
Yeah, that's a great question. And there's this zk researcher. He's from Soundless Protocol. He had pictured a near future where he calls it continuous proofs. So in the future, he feels that there's going to be proofs generated all the time, continuously. So that could be from all the Web3 sources like DeFi protocols, L2s, any application. It could be from even Web2 apps. Web2 apps can generate proofs as well to verify either computation or truth. And then there's this like budding area of Web4. Web4 has been now called like IoT, AI, augmented reality, and as well as virtual reality. So they're all generating proofs, and all proofs of different types. There are new proving systems, new proof types all the time. So there's like Circle Starts, Binius, and I don't know, even last quarter there were 12 research papers all around proving systems. So proof types can come from anywhere. We will build verifiers to support them for any new ones, but it really is based on the application and what they want to do. So, for example, if an application wants to use database queries and proofs related to the integrity of database queries, Space and Time offers that. They have their own proof type called Proof of SQL, and we do have a verifier that supports that. So anybody who wants to work with databases and verify their queries, they can send them. They can send their proof to us, get an immediate receipt, also get an aggregated receipt. So it really depends on the application that's sending it.
Okay, so it doesn't depend on the network itself. If it is compatible with zkVerify or not, it's depending on the type of the proof the network is sending.
Yes, exactly.
Yeah, and if there is a new type of proof you need to develop your system to enhance it somehow to get to add this support for this new type of zk proof, right?
I think you say it much better than I do.
Yes. Cool. I just repeating in order to understand better.
Yeah. Our interface is an RPC request, and we also have a package that is an npm TypeScript JavaScript package. So anybody could use that package to send us a proof, whatever type that we support, and you could listen for events. So they'll get a response immediately. If in that you can listen for errors and react to that as an application.
And in terms of networks to which you broadcast this zk verifications, what networks do you support? What it depends on?
Yes, we're always adding new networks as we speak, and so as of now in our testnet, we support Ethereum Sefolia, we support 8-chain Curtis, which is an Arbitrum L3 chain, and then we support our own EVM chain, which is Horizen Eon. The way we broadcast these aggregated receipts these aggregated verifications is that we work with a bridge provider, Hyperbridge, to radiate them out.
So what kind of real use cases zkVerify enables and make possible?
Yes, great question. In terms of partners and use cases now that we have, we are working with a company called Pixel Vault, and they're a gaming studio that also works with with Dave Chain and the ape community. And in games, there's this concept of random numbers. Random numbers are needed for like loots or for turn playing, and so there's often this a verifiable random function that you would call. You call that and you get a random number. But how can you tell that this random number is actually random? It has followed a random algorithm. So you could generate a proof, say what kind of algorithm that it's, what kind of random algorithm it's following. And zkVerify, we can verify that proof so that we can provide a provable random function. So that's one area in the area of games. Another is a provable lottery. So how can you tell that lotteries are being run in a way that is fair? And that can be encapsulated in an algorithm or a computation. A proof can be generated, and zkVerify can verify it. Really, any use case that involves proofs and folks, and to have it be verified very cheaply, that's what we unlock.
Yeah, I see. It's applicable to many different cases that show here. And in terms of rollups, how zkVerify can help us reduce costs?
Yes, and so that is definitely an area to save for rollups. And for rollup as a service providers, where zkVerify is one part of the modular stack, and that stack is the verification, where we will do the verification and essentially radiate it upward to the chains, and so we can bring costs lower in terms of verification, and any L2 can use that, or Rollup as a service provider, or any chain as well. So it is in terms of cost reduction, but also in terms of innovation. If a Rollup, if a chain wants to experiment with a new proof type, we can build the verifier for that.
Okay, and for the end users of the rollup, so do they get any tangible benefits of zkVerify being integrated into the RAS solution?
Yes, great question. I think from a user standpoint, it would be mostly seamless, almost as if just like any piece of infrastructure, they're not seeing the underlying technology underneath, but everything works as it is, but cheaper. So there'd be cost savings passed forward.
Yeah, everything is coming down to costs eventually.
Eventually.
Yeah.
Great.
So let's talk about your own blockchain network. I know that the system you provide for this verification is decentralized. Is there any particular reason why you need this decentralization? If we speak about zk verifiers.
Yeah, great question. We had thought about it internally. Definitely could be a centralized service in terms of verification, but we wanted to. We wanted to retain all the benefits of having a decentralized network of blockchain. So that includes censorship resistance, includes having this incentivized network of nodes to be able to participate and verify proofs as well. So those are the two key areas why we wanted to have a decentralized network.
I see. So there are usually two approaches to build your decentralized application. You can use the public network that is already existing, or you can use your own dedicated network. So which way you chose and why?
Yes, yeah, we went with the public network. We use a a framework to build our blockchain. It is a Rust substrate-based blockchain, and we believe in the modular stack. But even within the chain itself, it is a modular framework where we can add new verifiers as part of a runtime upgrade, which means that we don't have the need for hard forks. We can. It is a WebAssembly, and so any new verifier that we add, the node network immediately upgrades without hard forks.
Do I get it right that the reason why you choose to go with your own blockchain solution is the customization?
Yes, the customization is exactly it. The way we can customize new verifiers, we can also improve in terms of accelerating the verification process. We do add kind of like these pathways to accelerate the verification process by delegating it to the node.
Can you tell me about the incentivized testnet program, which is now live with zkVerify?
Yes, so zkVerify, we've been in testnet for about 6 months or so, and we're currently in phase 1 of the incentivized testnet. We urge folks to participate, and this phase 1, you could either build a verifier if there's a new proof type that you want, or a proof type that we don't support. The other part is building a demo app. We want demo apps showcasing the use of zkVerify and the verification network. So that's phase 1. Phase 2 is around any zk app. So it goes beyond the demo app. If you already have a zk app, please bring it. Could be a DeFi, a gaming app. So we welcome folks to use zkVerify.
Okay, cool. I would bring one if I had.
Yeah, I know.
So what are the plans for the development? If I can ask this question, could you reveal a little bit of your future destination?
Yeah, so before I go into the development, and you mentioned the app developers, we have been sponsoring hackathons. So we're part of ZK Hack Montreal, which went well. We were also part of East Sofia, East Warsaw, and there's an upcoming ZK Hack Virtual, ZK Hack V. So I urge folks to participate there. We're also organizing our own zkVerify hackathon, which will be coming soon. We also have a grant program open. And so anybody who has an idea for either a demo app or verifiers, feel free to apply to our grant program. But yes, in the near future, we are on the road to testnet, to mainnet. And so we expect to be in mainnet shortly with the new year. And we'll continue to scale out and make sure that we are mainnet ready. Meanwhile, we are also focused on the next iteration of Horizen, which is Horizen 2. So I'd mentioned that Horizen is a fork of Zcash, so it's on an older C++ stack, and we're going to take the entire stack and upgrade it to Rust substrate. And Horizen 2 also utilizes zkVerify as well for our verification purposes in some scenarios.
I see. And the last but not the least, in terms of the broad understanding of where we are going, in zero knowledge space, could you name some challenges and what are the future?
It's a great question. In terms of challenges, I think the field is moving very quickly, and there are new discoveries all the time. I think one challenge will be around standardization. So I think with us verifying all different types of proofs, we will come towards more of a standard in terms of verification. We are part of ZK Boost, which is a standards consortium. So we're working towards standardization. Another challenge, I think it's similar to what you said around like apps, use cases, continuing to build on new use cases and make them more mainstream. So I think the infrastructure is there's been a lot of work on infrastructure. So I think apps will follow with the infrastructure. In terms of the future, I think there's going to be even more collaboration at ZK Summit 12 in Lisbon just last month. There was I'm seeing like this like intersection of technologies. So zero knowledge proofs, snarks, they're being combined with other similar technologies like MPC. So there's this team called Tasio who's doing collaborative snarks. So they're using MPC plus snarks to create a collaborative snark. And then there's another company called Zama. They're doing a combination of snarks plus FHE, fully homomorphic encryption. And they're calling it, and it's private verifiable computation. So I see a lot of this like collaboration, and I think there's going to be even more of it, and I'm excited about it.
Yeah, I'm also excited about the collaboration between our companies.
Yeah.
And I really believe that with the help of this collaboration, we can make ZK Rollups cheaper and more affordable for the end users for the project that would like to run their own dedicated blockchain. So let's collaborate. Let's see where we go and eventually. And I see really good stuff behind this ZK technology.
Yes, I agree. Well said.
Thank you very much for coming to us. Thank you very much for sharing these highlights with us.
Thanks, Alex.
It's valuable.
Appreciate it. Yes, great to be here.